It's 2026, and NVIDIA just shipped a computer the size of a paperback that genuinely thinks it's a data center. It costs more than your rent. Let's talk about the DGX Spark. The pitch is simple and a little unhinged. A 1 petaflop AI supercomputer on your desk, sipping 240 watts. The reality comes with more asterisks than a phone contract. Buckle up. Quick context on why this thing even exists. Modern AI models are absolute memory gluttons. A 70 billion parameter model in 16-bit precision wants about 140 gigabytes of memory just to load. Your RTX 4090 has 24. The model takes one look, says no thanks, and throws CUDA out of memory. Your old options were grim. Rent cloud GPUs by the hour until your card declines, or build a server rack in your closet and pretend the noise is a feature. NVIDIA looked at that mess and asked one question. What if we cram an absurd amount of memory into a tiny box? That box is the DGX Spark. It began life as Project Digits, teased at CES 2025. The shipping unit fits in one hand, packs a 4 terabyte SSD, and pulls around 240 watts. That's less than your gaming PC spends on RGB. Running the show is the GB10 Grace Blackwell superchip. NVIDIA welded a CPU and a GPU onto one coherent package and shipped it. On the CPU side, 20 ARM cores, 10 heavyweight Cortex X925, 10 efficiency Cortex A725. Nobody bought this for the CPU, but it shows up and keeps the GPU fed. On the GPU side, Blackwell, 6144 CUDA cores and 5th generation tensor cores that speak 4-bit math in hardware. Tattoo that last part on your arm? You'll need it in 60 seconds. These two don't gossip over crusty old PCI. They share one coherent memory pool across NVLink C2C. Zero copying, both chips staring at the exact same bytes. And that memory pool is the entire reason you clicked. 128 gigabytes of unified LPDDR5X. More RAM than your whole team's laptop stacked together with leftovers. Now the box says 1 petaflop, 1,000 trillion operations every second. Sounds like a moon landing. Time to read the fine print, because this asterisk is doing Olympic floor routines. That petaflop is sparse NVFP4, 4-bit numbers. With sparsity tricks layered on top, you can count the precision on one hand and still wave goodbye. Run it in honest FP16 and the number faceplants to a fraction. Before you start typing in the comments, 4-bit is the clever part. Push 4 bits instead of 16, and you quadruple how much model squeezes through the same pipe. Blackwell does NVFP4 in silicon, and it earns its keep. Now for the part the marketing deck speed runs past. 2 words decide this entire machine. Capacity versus bandwidth. Capacity is how big a model fits. Bandwidth is how fast you shovel it through the chip. Spark bet everything on capacity and let bandwidth eat the loss. That 128 gigs runs at roughly 273 gigabytes per second, shared between CPU and GPU. For reference, a Mac Studio carries about triple that bandwidth. This is awkward. Why should you care? Generating tokens is bandwidth bound. Every single word the model emits has to drag the whole model through that 273 gigabyte straw. So here are the receipts. A 70 billion model in FP4 puts out 15 to 20 tokens a second. Fine for a chatbot. Push past 30 billion and interactive chat starts feeling like 2003 dial-up. How rough is that against the competition? 3 used RTX 3090s off eBay hit 124 tokens a second on a 120 billion model. The Spark manages 38. The flagship is 3 times slower. Big oof. So it's a $4,700 paperweight and we're done here? Not so fast. The benchmark everyone screenshots is single stream chat, and that is the one job Spark is genuinely worst at. Hand it a giant prompt, the prefill stage, and it chews through context fast. Run smaller models with batching, and it pushes thousands of tokens a second across parallel requests. As a serving box, the math flips hard. And here's the trick money can't fake. It loads a 70 billion, even 120 billion model at all. No sharding, no out of memory, no cloud invoice quietly billing your soul. Your 4090 simply cannot reach this room. NVIDIA rates it to fine-tune up to 70 billion parameters and run inference up to 200 billion. Chain 2 Sparks together over ConnectX networking, and you bully a 405 billion parameter model from your home office. Hardware is only half the con. Spark ships DGX OS with the full CUDA stack, the same software running NVIDIA's 6-figure data center DGX systems. Which means you prototype on the box at your desk, push the exact same containers up to a cloud DGX cluster, and nothing breaks. That workflow lock-in is the real moat, and NVIDIA knows exactly what it's doing. Now the wallet damage. It launched at $3,999 in October 2025. By February 2026, NVIDIA quietly slid it up to $4,699. Inflation, but make it silicon. Bonus asterisk. Some reviewers clocked units running at roughly half the expected power and performance depending on configuration, so your mileage may very literally vary. Let's settle who should actually buy this. Gamers? Hard no. This is not a 5090. It will not run Cyberpunk. Please put the wallet down. Chasing maximum tokens per dollar? Also no. A duct-taped multi-GPU Frankenrig embarrasses it on raw speed for less cash. Buy it for exactly one reason. You need to run or fine-tune genuinely huge models locally inside NVIDIA's ecosystem on a silent 240-watt box that fits right next to your keyboard. Researchers, indie AI devs, privacy-locked teams who legally cannot ship data to someone else's cloud. This thing is aimed straight between their eyes. Zoom out, because Spark is a trial balloon. The same RTX Spark silicon is landing in laptops from Dell, HP, Lenovo, Asus, MSI, and Microsoft Surface Laptop Ultra later this year. NVIDIA's whole bet is this: AI stops living in someone else's data center and moves on to the device in front of you. Spark is the expensive, weird, very first draft of that future. Is it worth $4,700 today? For almost everyone, absolutely not. For the right developer, it's the only box on Earth that does what it does at this size. The DGX Spark is flawed, overpriced, bandwidth-starved, and somehow still kind of essential. That's peak NVIDIA, honestly. If your models keep dying on out of memory and your cloud bill keeps climbing, you already know whether you want one. This has been the DGX Spark in way too much detail. Now go build something that earns back the price tag.